And hello, welcome everyone. Today I want to talk about unit safe calculations in Rust for noobs. So I'm a kind of a Rust noob here, so I'm still learning this, but I found some really great packages for unit safe computations. Now, unit safe computations are pretty important, and because you want to make sure that your units stay consistent, and if your units are not consistent, it's a very common source of mistakes for numerical calculations in engineering, science, and what have you. So there are basic two basic packages I want to talk about. One is called UOM, units of measure, and this is the one I mainly found to be useful. UOM already has a lot of predefined units for you. Okay, so this is one package to use, and if you don't want to do so much work and the predefined units are enough for you, if those are enough for you, then you're pretty much fine with UOM. So units of measure. So you can see there are lots of units here. You can go to the UOM source directory. Under the SI directory, you will see all the available units here. Now yeah, so this is what you can do. Now the other what do you call that? Let me check this. Hello, yeah. The other quantity, so to speak, the quantity package, as in for unit safe calculations. The other package you can use is this one called quantities. Now with there are pros and cons for using UOM and quantities. With quantities, you kind of they are less, so to speak, they are less predefined quantities, and you have to enable these features in cargo. However, if you want to make custom units, it's much easier. So these are pros and cons. Whereas with the UOM, making new units is a little bit harder, a little bit more code, a little bit of a steeper learning curve. But with quantities, it's easy to make units. However, let's say if you have what I tried before, what I realized with quantities is that you can only make derived units. For example, area. If you take a look here, at this part, okay, you're actually defining a new quantity called area. So area is length times length. So that's not a problem. That's quite straightforward. However, when you think about it, there are many ways to calculate area. If you divide mass by mass flux, for example, you will also get area. However, if you try to do multiple ways of calculating a quantity, for example, if you want to calculate energy, you can use energy units, you can use force times distance. However, you can also use heat capacity times mass flow rate times volumetric flow rate, or MCP delta T. Yeah, so it's mass flow rate times CP times delta T, which is the change in temperature, then you times time. And that is also an energy calculation. So you have multiple ways of calculating energy or calculating an area quantity. This thing doesn't do that as well, to be honest. You have to do a lot of manual calculations here and there, as I found. So if you have area, you can only use a length times length in order to give you an area. You have to like do so it's a little bit more tedious if you want to do multiple calculations like that, multiple ways of calculations. But UOM here is, I guess, more developed. And if you take a look at the number of stars in the GitHub repository, yeah, it is made by this GitHub user called I Like Turtles. It's very meme-like. Yeah, well, it doesn't just have meme potential, but it has 710 stars, so you know that this is a good package to use. So in this video, just to demonstrate the UOM, I want to demonstrate how Reynolds number is calculated. So, well, let's try having Reynolds number. So this is of course C# code, which I will actually wanted to convert into Rust code. Okay, and one of those important functions there is calculating Reynolds number. Reynolds number is quite simple to calculate. It's just density or rather density times velocity times hydraulic diameter divided by dynamic viscosity term. So I'm just going to make a directory called demo, and I'm going to go there and try to demonstrate how to do the Reynolds number calculation. Now I've already done that here in my sample code. I have this units playground repository, but I'm not. This one is very messy, so I'm not like making it public. I'll just do this thing today. Okay, let me move the demo. I will change this name to Rust UOM demo. Okay, maybe I'll yeah. It's a good name to show what it does. So go to Rust UOM demo. What I'll do now is I'll do a cargo init in order to get the cargo project running. And let me shift to the left and reload. Okay, and I'll go to source main.rs and I'll shift to this directory just to clean things up. Okay, so I'm over here, and what I like to do now is, well, there's a hello world function here. All I need to do is cargo run and it will do this hello world. Now the basic steps to get units of measure UOM running are just use cargo add UOM. Okay, cargo add UOM. Okay, so this is now added cargo. We have now added cargo UOM here, and we can either use cargo build, but you can use cargo build to build this, but I like to use cargo watch instead. Cargo watch is a way, like more friendly way of doing a repo like sort of programming, where I change the source files here in main.rs. I change the source files here, and as I change the source file here, the compiler will keep giving feedback. So this is how I like to work in NeoVim. Okay? It's not, I wouldn't say it's the best way, but it's a way I find comfortable. Okay, so cargo watch, and I can put execute run, and anytime I change, I will just maybe I do function Reynolds demo. I'll call this Reynolds demo, and I'll say print line Reynolds demo. Okay, I assume you know how to use a little bit of Rust, so I'm not going to do much here. Okay, so here it will still be waiting for file lock on build directory. So I'll just wait for it a little bit more. Yeah. Okay, so it does say this hello world and everything, so that's fine. I can run the Reynolds demo thing here. So you can see it does the Reynolds demo. Okay, so this is how we can so-called program using cargo watch. It's very convenient. Okay, so next thing I want to do is just to do the basics over here. I'm kind of copying and pasting from here. So the way to use UOM over here is extern create UOM, use UOM SIF32, blah blah blah. So all of this here I will just start to use, and this is the UOM code, units of measure code. Okay, so I'm just going to copy and paste everything here. It will complain about unused imports, but doesn't matter. Okay, and this is a velocity acceleration calculation kind of a method, and over here is the UOM demo. So I'll just put this as UOM function UOM demo. So this is quite easy. Paste it here, and that'll be done. Okay, and then I can just do this. Let me do a print line of acceleration. Okay, the proper way to format is either use this curly braces or actually something a little bit more what do you call that? You should use it in a more what am I saying here? I lost my train of thought. Okay, you either use curly braces or there's a slightly more complicated way to print, And the way to print, you want to go and see, the way to print all these quantities, you can actually go to the UOM examples and you go and see units over here. So the way to print is to use either these curly braces with the format display style with the abbreviation, which I find a little bit more awkward to use. The way I like to use is, well, I will use this question mark in between. You see, curly braces with a question mark in between. I'm a Rust noob, so I'm not going to really delve into what that means. I myself don't know. I'm just copying and pasting code that just works without full understanding of it. But if it works for the purposes of this video. Okay, so I'm going to put UOM demo here, and this should actually print the acceleration for us, 22.2 meters per second. So this is slightly over 2 times of Earth gravity. Okay, so here is how you do the UOM. Now, Reynolds number, for calculating Reynolds number, I can do something similar. So let me put a UOM demo code block here, block or functions. Okay, so I also want to have a way to calculate Reynolds number. Reynolds, okay, so you see over here there's a calculate acceleration thing. So I can actually go up and I will paste this. I will say instead of acceleration, I actually want to calculate the Reynolds number. So I put calculate Reynolds. What do I need here? Well, velocity, density, hydraulic diameter, and kinematic dynamic viscosity. I mean, the other way is to use mass flow rate. Yeah, but I think I'll just use the velocity method here. So let me put velocity here. I mean density, pardon me. And let me delete this. Let me go to rho, and rho can be a density. U is velocity. I don't use time. Okay, I don't use time. Rho U length D. Okay, diameter. I'll put hydraulic diameter, and I can put this as a length. And what's the last one? Mu, which is dynamic viscosity. Now, how do I know all these names? Okay. Also, I want to return a float 64 because Reynolds number is dimensionless. Okay. So now it's complaining that things like density, they're not found in this scope. Dynamic viscosity, also not found in this scope. Okay, how do you do this? Right. So first thing first, I need to sort of import some things, right? UOM SI mass density, that's a suggested thing. Okay, but if you want to know which file to use, how to import density. All right, so go to UOM, go to source, UOM source. Okay, after going to source, go to SI. So you'll know all the things here. So they actually make a difference, a kind of a difference between mass density and other kinds of density. So here is the name of the Rust file called mass density. So that is the file we should be using. Okay, so I'm going to put use UOM SI mass density. Okay, and then let's go inside the density folder. And what is the quantity called? It's called mass density, okay, with the capital M. So I cannot use this just density like that. I have to call it mass density. So where do you find that structure? You find that structure within this quantity code. The quantity will be called mass density. This is the name of the structure or type, okay, or class. But Rust has no class, so that's not technically correct. Okay, so I can use the UOM SI mass density. Actually, I don't need this. This should almost compile, but it won't compile because there are two problems. One is that dynamic viscosity is not found, and okay, dynamic viscosity is not found, and then also we need to return a float 64, which is a double. Okay, but why isn't dynamic viscosity found? Okay, if as of the time of recording this video, if you look at here, you look at the GitHub of I like turtles UOM. Yeah, there is a dynamic viscosity, and the quantity is really dynamic viscosity, as you can see here. However, this is on the master branch. Okay, whereas if you try to take a look in older versions, the versions that we have is actually 0.33.0. And how long ago was it released? 3 months ago, June 28, 2022. Okay, how recent is dynamic viscosity? You take a look at dynamic viscosity, this was released last month, around August. So the version that is released on the crates.io is like not up to date with the master branch. The master branch is the most recent, and only the master branch at this point in time has dynamic viscosity. Okay, so the quick question is, how can we then make sure this dynamic viscosity is working? So we have to stop compiling for now, stop the cargo watch. Okay, what we need to do is, well, cargo add help add. Okay, because to add we need to use cargo add in order to add new packages. Well, there is an option under cargo help add, like over here, cargo add. This is how you use it. One of them is to use the options, cargo add options crate. The other thing is to just add the crate directly from the GitHub repository. So you can see cargo add -git, and then you put the URL there, and then put the git URL and the crate. Okay, the crate in this case, as you can see, or maybe not now, you go to the cargo toml file, the crate is named UOM. Okay, the crate is named UOM. And you can see there's this external crate UOM. So that is the crate we are aiming for. So it is cargo add, cargo add. Well, I need to use git. And what's the URL? Okay, the appropriate URL is go to this, go to here and use GitHub I like turtles UOM. Okay, so put a git URL here, and then the last part will be you need to specify the modules. If you don't specify the modules, you will get this error. You see, multiple packages found at GitHub I like turtles UOM, addition check, feature check, UOM macros. So don't do that. Make sure you specify UOM like this. Okay, so now all these are here. It has the features auto convert, F32, F64, so on and so forth. And now my linting engine is still saying, oh, there's some problem here. We don't have dynamic viscosity in this scope. So, but if I do a cargo watch X execute run, okay, this will rebuild all the packages, and now the Rust analyzer will like, okay, maybe this thing can actually work. So what is this going to do? It's going to update the UOM units of measure crate directly from the GitHub repository. And as of this time, this GitHub repository is the one that has the dynamic viscosity unit. So this is useful if you want to get the most up-to-date versions of UOM or any other cargo thing, is to download it straight from the Git repository. So now you see that the dynamic viscosity here is not, there's no more problem with the dynamic viscosity type because we use the latest version that has the dynamic viscosity type. And now we just need to calculate the Reynolds number. Okay, how do you calculate the Reynolds number? Well, just like this, let Reynolds number equals to rho times velocity times hydraulic diameter divided by mu. Okay, a little bit ugly code, but it will work. Okay, maybe I'll do it like this so as to make it a bit neater. Okay. So and then I'll return Reynolds number. And then you will find that there is a problem. It says, wow, there is a mismatch type. Mismatch type. It says we expected F64, we found structure quantity. So how do we deal with this? Okay, a very simple thing. Okay, you just actually access the value from the Reynolds number. This is the short version. Access the value from the Reynolds number and you will get the correct return type. Okay, it says now there's a problem. Okay, now there's another problem. It says expected float 64 but now found float 32. So, well, the thing, well, we can just follow what Rust says. The Rust compiler says. I don't even know this, the exact tips off the top of my head, but the Rust compiler will tell you what to do. You can convert the F32 and the F64 using the into method. So I can use the into method right here, and now it will compile properly. Okay. So how did I know? How did I know where to get this value attribute or value method or whatever property from? Okay, so if you are not interested, just skip this part, but I'm just going to explain. Okay, what I was doing is that I found earlier, okay, I found earlier in the error messages from the Rust compiler, you can see that it says over here, Reynolds number, expected float 64, found struct quantity. So you know that this Reynolds number here is not a double per se, it's not F64, it's a struct or a class, so to speak, a class or structure. This struct over here, is basically, you know, I need the what do you call that? Yeah, I need to look for the class or structure. There's no class in Rust, but I'm just used to classes because I used C# before and Python, of course. We found the structure quantity. So let's look for the structure called quantity and see what's inside. So the way I find the structure quantity, well, this is where the structure quantity page is, but to look for it, go to the docs from the UOM page. Open the docs in a new tab. Okay, and you look for this thing called all items, and then you search. The first thing that actually appears is SI quantity. This is the base structure, and you can just click on it, and you will actually arrive there in UOM SI. It's this same page here. So just over here, you can actually see three things already. Pub structure quantity DUV, where D is dimension, U is some unit, V equals to the number plus the conversion. So here are the types that are specified in this DUV thingy. And then there are three things right here. Right? So there's dimension, there's units, and there's value. Okay? So the thing you want to kind of extract out is this thing called value. You know why? Because if you actually look at this length, for example, constant L, which is a length, equals to length. Dimension is some phantom data. I don't know what phantom data that is. Units is another piece of phantom data. Okay, but the value here is the number that you want. So how do I know to access the value? Is by looking here. All right, when you actually create a new length object or new quantity object, I'm actually specifying that this actually has the value term is actually where I put the number, and therefore if I want to access that number, I also have to use this value term here. Okay, now we also ran into the problem of having the F32 right here. The float 32 is the normal float value, but how about if I want F64 by default? Yeah, I think I can actually change this into F64. Change your use UOM SI into F64, and then this will be okay. I will not need my into. Okay, so you change your UOM SI to 64 so that we can keep using doubles by default. If not, you can just use the F32 and use the into method. Okay. Yeah, so both of this is fine. Now let's try calculating the Reynolds number. So how do we actually instantiate new quantity objects? So you can see here, over here it says let length equals to new kilometer 5.0, right? So that's the syntax we use. And over here we actually needed to import the units. For example, here we have kilometer, right? So you actually needed to import the units here, kilometer, and over here we also need the second. So we need to import units for length. Okay, actually I want to add the meter. Okay, import units. Okay, use UMSI. Of course I can copy and paste, but I'm not going to bother. So I'm going to put this UMSI meter. So this is one way. I'm going to yank this and 3p. So what else do I want? I want a unit for not just I want a unit for hydraulic diameter for sure. I want a unit for my density as well, velocity and mu. So how do I know where to grab all this from? So the first thing, again, rho. If I look for my density will be rho, which is under mass density right here. Okay, mass density.rs. So I need to look for mass density.rs. So mass density.rs will be this first thing over here. That's where I grab the unit from, mass density. Okay, and then what are the units within mass density? So let's look at mass density inside. Mass density has a few units here. Yotogram per cubic meter. We don't want something so much. We just use kilogram per cubic meter. So you can see this long list of units, and you can see the at kilogram per cubic meter with underscore. This is the correct unit to use. So you just copy and paste. Okay, I can do this also, kilogram. Okay, maybe it doesn't have autofill here, which is, well, it's a pity, but yeah, maybe my LSP is not that good. So this is how you get the correct unit. Okay, so next thing to look for is velocity, the unit for velocity. How do you look for unit for velocity? Same thing again. Go over here, go and shift. Let's look for velocity. So we have a velocity.rs. So the file here we need is velocity. Okay, and then what is the proper unit? The proper unit we want is something SI, meter per second. So we just copy and paste meter per second. Okay, so copy and paste meter per second. Okay, next thing is to have this SI unit length meter, which I will not change. The last one is dynamic viscosity. So again, go up, go to the Rust file which specifies dynamic viscosity. Okay, dynamic viscosity. Okay, here's where it is. Let's look for a unit. We have a few units here. Okay, the first unit is the SI unit, which is Pascal second. I'm just going to copy and paste this. And the name of the Rust file is dynamic viscosity.rs. So let's go change this to dynamic viscosity with an underscore here. And I'm going to paste this Pascal second here. Now we have imported all these units, we are able to create new quantities and load them into our Reynolds number function. So let maybe u, okay, or rho equals to, what is this? This is a density. I want to make a new density. And then what's the unit? Kilogram per cubic meter. Yeah, and after that, just put there, as you see in the UOM demo, just put a unit, a quantity inside. So I'm just gonna put 1000.0 as my quantity. Okay. And it says density is now not found in this scope for some reason. Why? Because this is not the correct type. I need to get out of the habit. It has to be mass density. Okay, so rho is the mass density. Next thing I want to look for is v, which is the velocity. So rho u is equals to velocity. Okay, new what meter per second. Okay, and velocity maybe I'll put 0.005. Let d equals to, okay, it's unused variable. D equals to what? It's a length. Okay, it's a length. As you can see over here, the unit is length. If you want, you can actually go inside the same file with the same procedure. We see what the correct structure is. Okay, but here we already know it's meter. We use the capital length with capital L, and we use meter for the unit. What's the typical unit? Maybe 2.88 e minus, maybe e minus 2. Okay, let's see whether this works. Save. Okay, it works. Let mu equals to dynamic viscosity. Mu. What's the unit? Pascal second. And then we'll just put something like 0.001. Okay, I think this is water viscosity, but I can't remember off the top of my head. So next thing is to let Reynolds number equals what? Calc Reynolds, okay, rho, u, d, and mu. Okay, of course you can join everything together as well, like that. That should be fine. And let's print line Reynolds number equals 2 curly braces, and then let's put the Reynolds number here, and we are done. So you can see the Reynolds number is very low, 1.43 something. So yeah, this is how we do it. Okay, so the code. Yeah, I'm not going to upload unless, yeah, because I'll probably have other repositories that have a similar code. But this is just to demonstrate, for example, how to calculate Reynolds number using the UOM crate in Rust. I hope this is helpful to get you started off to unit safe calculations.